everyone, welcome to Modern Application Development Part 2. Okay, I had already mentioned or rather demonstrated a little bit about strings, right? As I had mentioned in the case of strings, most strings expect UTF-16 encoding, and functions like length can give surprising results. I mean, when I say surprising, you need to just keep in mind that you need to compute taking into account the fact that it is in Unicode and UTF-16 format. But it's not that it's going to give you random results. It's predictable, but you need to know how to actually compute it. You can have variables in other languages, but please keep readability in mind, and generally better to avoid these unless absolutely necessary. Undefined and null, as I mentioned, are the so-called non-values, right? The difference between these two is that undefined is usually used for things that have not yet been given an initial value. Right, so when I declare an array, an empty array with 3 elements in it, the elements in it are undefined. Okay, but if I actually declare the array and I put null into the values over there, then they are null. So that's a slightly different thing. You explicitly want it to be null rather than just leaving it undefined and unknown. Okay, so there is a subtle difference. In a lot of cases, they can be used interchangeably, meaning that you can use undefined where you would like to compare against null or vice versa. But it's probably good to keep the context in mind when you are using it so that your code is clear, right? And you know when you want to use undefined or when you want to use null. Operators and comparisons, as I mentioned, right? You have addition, subtraction, coercion, which can be problematic. Comparison, preferable to use strict equality, right? Wherever possible. So all of this is important when you are trying to implement iterations or conditions. The scoping of variables we already went through in the demo, right? And what we saw there was any non-reserved identifier can be used as a variable name, right? Scope is something that we need to be careful about just so that we don't end up declaring a variable with the same name as something else in a library. So whenever we declare a function or a block, you can use let in order to have the variables inside it without going and messing up variables that have been declared elsewhere. So let and const, right, are the two mechanisms used for declaring variables. As I said, const declares what's called an immutable object. The idea behind declaring something as const is that whatever you have assigned into that variable cannot be changed. That's a bit tricky because what it actually means is, let's say that you assign an object into a variable, something inside the object can still be changed, right? That is not restricted by const, but the object itself cannot be reassigned, or rather the variable cannot be reassigned. Let, on the other hand, can. So if you are implementing something like a for I equal to 0 to 10 loop, I probably has to be declared as a let variable so that it can be updated each time you go through the loop. Now, having done all of this, it's important to also understand a little bit about control flow, right, in JavaScript. And as part of that, what we are going to do is, we have already looked at the basic idea of conditions, right? And an example of this would simply be to say, okay, I can declare a variable, I can check if the value of the variable is equal to something else, right? And based on which of these got executed, right, I would say, oh, of course, 3 is not equal to 5. On the other hand, if I change the value of the variable out here and I run it again, then it would print whatever came out in the first one, which says basically what, right? It doesn't matter, this is just a demo, right? What about iteration? This is an example of how we would write iteration in a language like C, right? And what would it do? It would, we ran into a problem, right? I'm trying to basically use const over here. What does it mean? I've declared x as a constant and I'm trying to do x plus plus, meaning that I'm trying to change its value, right? This is where the trouble comes in. So what do I need to do? I can have let, and that should then not be a problem, right? If I run this, sure enough, it prints out 0, 1, 2, 3, 4, right? So x starts from 0, goes up to 4, exactly the way that, in a C or Java like language, this is what a for loop would look like. But this business with const is not quite as straightforward as that. Supposing I have something like this, const v is equal to 1, 2, 3, 4, and then I do for const x in v. Now look at this, instead of let, I'm using a const over here. Okay, and going by the previous argument, it should say that x is changing its value each time through the iteration. So how can I declare it as a const, right? But this works, right? Why does it work? Well, because even though x is changing, it is only changing from one iteration to the next, right? And within the scope of the function, that is to say this open brackets, close brackets, the value of x is not being changed. On the other hand, this x plus plus over here actually has to get run within the scope of this function that we have, right? It has to be incremented, and then I need to check whether it is still within the bounds that I'm working with. Okay, so because of that, this const over here, when I use the const x in v, works fine, right? Where v is basically an array. We have not yet looked at arrays, we'll look at them later, but you can broadly get an idea of what this is, right? It's just a collection of different values. Now the interesting thing here is, you will notice that what got printed was not 1 2 3 4, it was 0 1 2 3. So in other words, what has happened is, when I do this in, the values that x is getting are not actually the values of v, it is getting the index values, right? So instead, if I print v of x, then I would find that I should actually get the values 1 2 3 4. Sure enough, that's what happens. Okay, but there is another form of iteration, right, where instead of in, I can use of. What happens if I run this? Here the x will actually take the values of v. Okay, so x of v basically means the values of v, right? Not just the values, the indices that are present in v. It's a bit of a subtle difference, you need to keep it in mind. Mostly of should be safe for your iterations, right? There are sort of subtle things that you need to keep in mind at some point, but you can probably just keep it simple, and of should work in most cases. But it will give you the values and not the index, right? As you can see, it runs and prints out 1 2 3 4. Okay, what else? So we have looked at the basics of control flow. There are a few other things, there are while loops, there are break and continue, very similar to what's used in Python, right? And also something called a switch statement, which would be familiar to those of you who are coming from a C or Java background, where you can basically compare against different options, and instead of doing if, else if, else if, else if, you can just do a single switch statement. I'm not getting into the details of these at the moment. I would recommend that you look at the language reference to see good examples of those as well. Now, what's a function, right? A function is essentially a reusable block of code, right? It can take parameters or arguments and perform certain kinds of computations, right? And the interesting thing is, functions are themselves objects that can be assigned, okay? There are multiple different notations that we can use for function. The most straightforward one probably is what, this would be the equivalent of a def declaration in Python. Function add of x, y, return x plus y. This is just a statement that declares a function, tells you what the functionality is, and you can thereafter use add x, y, just like you would in any other programming language. This in the middle column is something which is actually called a named expression, right? If you look at the notation here, I'm saying let, right? And I'm saying add is equal to a function. Okay, so in other words, I'm taking this entire function x, y, return x plus y. This statement out here is not actually a statement, it's an expression. In other words, it has a return value. Notice the difference. Over here it's directly function of x comma y, whereas over here it was function add of x comma y. That made it a statement which does not return a value, right? Whatever it returns, that directly goes into add. But over here, when I just give function of x comma y, that's actually something called an anonymous function. I'm declaring the function without giving it a name. Okay, and when I declare an anonymous function like that, it gives me back the content of the function, which I can then assign into a variable out here. Okay, there is one more notation which is usually called the arrow notation. Over here, this is preferably used only for very simple kinds of functions. Although unfortunately you will find that there are, especially when you are looking at front-end code and so on, you will find it being used quite a lot for fairly large and complex looking functions, right? But ideally it's best suited for very small and brief functions, something like this. Let add equals, it takes two inputs, implies or gives x plus y, okay? So add basically is declared as a function that takes x, y as input and gives x plus y as the output, okay? Now this notation here, right, where I'm basically saying function return hello is something that's called an anonymous function. I'm taking that anonymous function and binding it into a variable called x, okay? This is a valid way of declaring functions. You can get any kind of function in this way. Now you could go one step further and basically say, you know, I declare this function, I tell what the functionality is, and then I immediately invoke the function, right? This parenthesis over here at the end is what is actually called invoking the function. I'm actually invoking it right there, okay? If I did not have this open parenthesis, close parenthesis over here, this starting with the function would sort of be taken as a statement and would not get evaluated. But if I have this, right, this notation as seen over here, what it is actually doing is it's declaring a function, saying this is the functionality, immediately invoking it and moving on. So what happened? I can't reuse this function because I never gave it a name. I've just declared it and invoked it. This is effectively just the same as creating a block, right? I could have just used open parenthesis, close parenthesis, and you know, whatever was in there would have got done. I could have just, you know, returned hello. Well, I can't do a return, unfortunately, right? But it would have sort of probably printed that value out, right? So this kind of a thing is what's called an IIFE, immediately invoked function expression or function execution, right? Now, as far as possible, avoid them because they were required for older versions of JavaScript that did not have good scoping rules. They did not have let and const in particular, right? And an IIFE was a very good way at that point of getting around that scoping because var still had function level scope, okay? So because of that, people tended to use IIFEs. I think they were called IFEs or something at that point, but nowadays there's really no good excuse for using it, right? And there are some people who feel that this makes it easy to read, but for the most part, especially for someone new to the language, it just makes it more difficult to understand what's going on, right? It's always better to explicitly declare a function and then call it, okay? So let's look at some basic examples of functions, right? Like I said, I can declare a function. I am also going to use this built-in function type of, which takes in another identifier or a variable, right, and gives you some information about that identifier, right? So in this case, I'm going to say what is the type of add, and then also call add with the values 2 and 3 as input, right? So what happens? The first thing is I see that the type of is reported as function. Good, so it explicitly found that this is a function. And of course, when I called, you know, add, it gave me the result. Nice to know, okay? Now, here's the interesting thing. I can actually add something to that function, right? Add.v, and this is something strange. I mean, this is, we'll get to this later, but I'm basically creating an object and assigning it as part of v, okay? And if I ask it, okay, what is add.v, or if even add.v.a, right? All of these things basically run through, and I can see that it is going to print that out. Add.v gets reported as this object, add.v.a actually gets this value 3, and that gets printed out, okay? So this is what I meant by functions can themselves have objects inside them, right? An object can have functions which are usually called methods, but what does it mean if a function has an object inside it? It's not very clear. The language allows it, that doesn't mean there's necessarily a good reason to use it, okay? So probably best avoided. We can also use the, in fact, just let me keep this, the basic function declaration. I'm also going to use the arrow notation out here, add one, and you know, let it also run directly as an anonymous function, right, where I don't give it a name. I just have to give console.log xy return x plus y and immediately invoke it out here 2 3, right? So what happens over here is line 93 basically declares a function, says that the function should return x plus y, immediately gives the function two parameters 2 and 3, evaluates it, logs it to console, and is done. Okay, so this is an immediately invoked function expression, right? Was there any need to do this? Well, I could have probably just written x plus y in this case, right? 2 plus 3, right? I don't really gain anything because it's not like I can reuse this add function. I've already invoked it with the values 2, 2, 3, okay? There are certain scenarios where having this kind of IIFE helps, but for the most part it's probably easier and clearer to actually declare your functions explicitly, right? Okay, now similarly we can also have add2, which is once again declared as a function, and then I can look at all three of these, add1 and add2, and okay, I need to uncomment this. And what we will find is that type of add, type of add1, type of add2, they are all functions, right? Even though they were declared in different ways. One was using function, another one was using the arrow notation, another one was using a named bind to an anonymous function, right? All of them work the same way.